Exercise 4.1, Question 2. Represent each situation as a quadratic equation. Part 1. A rectangular plot has area 528 square meters. The length is 1 more than twice the breadth. Letting breadth equal x, length equals 2x plus 1. Product x times 2x plus 1 equals 528, giving 2x squared plus x minus 528 equals 0. Part 2. The product of two consecutive positive integers is 306. Let the integers be x and x plus 1. Then x times x plus 1 equals 306, giving x squared plus x minus 306 equals 0. Part 3. Rohan's mother is 26 years older than Rohan. The product of their ages 3 years from now is 360. Let Rohan's current age be x. Then in 3 years, Rohan is x plus 3 and mother is x plus 29. Product x plus 3 times x plus 29 equals 360. Expanding x squared plus 32x plus 87 equals 360. Rearranging x squared plus 32x minus 273 equals 0. Part 4. A train travels 480 kilometers. If the speed were 8 kilometers per hour less, it would take 3 hours more. Let speed equal x kilometers per hour. Time difference equation, 480 over x minus 8 minus 480 over x equals 3. Cross-multiplying and simplifying x squared minus 8x minus 1280 equals 0. Exercise 4.2, Question 1. Find the roots by factorization method. Part 1 x squared minus 3x minus 10 equals 0. Split. -5 and 2 give some -3 and product -10. Factorizing x minus 5 times x plus 2 equals 0. Roots x equals 5 and x equals -2. Part 2. 2x squared plus x minus 6 equals 0. Split. 4 and -3. Factorizing. 2x minus 3 times x plus 2 equals 0. Roots x equals 3 over 2 and x equals -2. Part 3. Root 2 times x squared plus 7x plus 5 root 2 equals 0. Split. 5 and 2. Factorizing x plus root 2 times x plus 5 equals 0. Roots x equals -root 2 and x equals -5 over root 2. Part 4. 2x squared minus x plus 1/8 equals 0. Multiply through by 8. 16x squared minus 8x plus 1 equals 0. This is 4x minus 1 squared equals 0, a perfect square. Repeated root x equals 1/4. Part 5. 100x squared minus 20x plus 1 equals 0. This is 10x minus 1 squared equals 0. Repeated root x equals 1/10. For parts 4 and 5, the discriminant is 0, confirming equal roots. Exercise 4.2, Questions 2 through 6, Word problems by factorization. Question 2 Part 1 Marbles x squared minus 45x plus 324 equals 0. Factorizing x minus 9 times x minus 36 equals 0. So x equals 9 or x equals 36. John had 9 marbles and Giovanni had 36, or vice versa. Question 2 Part 2 Toys x squared minus 55x plus 750 equals 0. Factorizing x minus 25 times x minus 30 equals 0. 25 or 30 toys were produced that day. Question 3 Two numbers with sum 27 and product 182. Let one number be x. Then x times 27 minus x equals 182. X squared minus 27x plus 182 equals 0. Factorizing x minus 13 times x minus 14 equals 0. The numbers are 13 and 14. Question 4 Consecutive integers with sum of squares 365. Let the integers be n and n plus 1. Then n squared plus n plus 1 squared equals 365. This gives n squared plus n minus 182 equals 0. Factorizing, n minus 13 times n plus 14 equals 0. The integers are 13 and 14. Question 5. Right triangle with hypotenuse 13 and altitude 7 less than base. Setting base equals xx squared plus x minus 7 squared equals 169. This gives x squared minus 7x minus 60 equals 0. Factorizing x minus 12 times x plus 5 equals 0. Base equals 12 centimeters, altitude equals 5 centimeters. Question 6. Pottery x articles at cost 2x plus 3 each, total 90 rupees. X times 2x plus 3 equals 90. Giving 2x squared plus 3x minus 90 equals 0. Factorizing, 2x plus 15 times x minus 6 equals 0. X equals 6 articles at 15 rupees each. Exercise 4.3, Question 1. Find the nature of roots. Find them if real roots exist. Part 1. 2x squared minus 3x plus 5 equals 0. A equals 2, b equals negative 3, c equals 5. D equals negative 3 squared minus 4 times 2 times 5 equals 9 minus 40 equals negative 31. Since d is less than 0, there are no real roots. Part 2. 3x squared minus 4 root 3 times x plus 4 equals 0. A equals 3, b equals negative 4 root 3, c equals 4. D equals 48 minus 48 equals 0. Since d equals 0, there are two equal real roots. The repeated root is x equals 4 root 3 over 6 equals 2 root 3 over 3 equals 2 over root 3. Part 3. 2x squared minus 6x plus 3 equals 0. A equals 2, b equals negative 6, c equals 3. D equals 36 minus 24 equals 12. D is greater than 0. So there are two distinct real roots. Using the quadratic formula x equals 6 plus or minus root 12, all over 4. That simplifies to 3 plus or minus root 3, all over 2. The two roots are 3 plus root 3 over 2 and 3 minus root 3 over 2. Exercise 4.3, Question 2. Find the value of k so that each equation has two equal roots. Part 1. 2x squared plus kx plus 3 equals 0. For two equal roots, the discriminant d must equal 0. D equals k squared minus 4 times 2 times 3 equals k squared minus 24. Setting d equal to 0, k squared equals 24, so k equals plus or minus 2 root 6. Part 2. Kx times x minus 2 plus 6 equals 0. Expanding, kx squared minus 2kx plus 6 equals 0. Here a equals k, b equals negative 2k, c equals 6. D equals negative 2k squared minus 4 times k times 6 equals 4k squared minus 24k. Setting d equal to 0, 4k times k minus 6 equals 0. So k equals 0 or k equals 6. But if k equals 0, the x squared term disappears and the equation is no longer quadratic. Therefore k must equal 6. These problems illustrate how to work backwards from the condition of equal roots to find the required value of a parameter.